Hi everyone. Let's go through this whiteboard exercise where we're given a wave function at t equals 0, and we're told it's in this superposition state where there are two contributions, one term proportional to the stationary state psi sub 1 and the other proportional to psi 2. Okay. We're first asked to find the full time-dependent wave function. So we want to find psi of x t. Right? So the important thing to recognize here, right, is that this wave function really is the sum of two stationary states. Psi x t equals 0 is a sum of stationary states. Right, so it's already in the form of that sum where we can recognize that, right, the coefficient in front of psi 1 is square root of 2/3, and let's call that with c1 and c2 equals 1 over root 3. All others are 0. So the key, right, is to recognize that, right, each one of these contributions time evolves with the appropriate phase factor. So writing the result down, we get psi of x t equals this square root of 2/3. Now our exponential factor is e to the minus I e sub 1 t over h bar psi 1 of x plus 1 over root 3, whoops, I forgot my phase factor here, e to the minus I e2t over h bar psi 2 of x, right? And I could go and write down E1 and E2 in terms of fundamental quantities, but maybe I'll just leave it in this form for now. Okay, so part B, right, asks us to find the probability that a measurement of the particle's energy gives us E1, and that, from our class discussion, we know is equal to C1 modulus squared. But we already identified what the C1 was. It's this factor of root 2 over 3. So here it's pure real. So we have root 2/3 squared, or just 2/3. So there's a 2/3 probability of finding the particle's energy being equal to E1. In a similar way, the probability that the energy is E2, is measured to be E2, is C2 modulus squared. And that, right, is also pure real, so we have 1 over root 3 squared, or 1/3. Notice, by the way, that the probabilities sum up to 1, just like we would expect for a well-behaving probability. So the last thing we're asked to find here is the expectation value of the energy, right? So writing that down, right? So it's going to be, right, sum of En times the probability of getting that energy, right? And so there's only two terms in the sum for us, right? So we have a 2/3, so we have E1 times the 2/3 probability of getting it plus E2 times the 1/3 probability of getting that. Now the question asks us to write everything in terms of E1. right? Remember that E sub n equals n squared pi squared h bar squared over 2m L squared, right? So because of this n squared dependence, right, notice that E2 is going to be 2 squared times E1 or 4 E1. So if I just go and take that and plug that in, oops, this pen isn't feeding, and I just plug that in there, I end up with 2/3 E1 plus 1/3, so E2 is now 4 E1. And so if I just slide this up a wee bit, so I end up with 2/3 plus 4/3 equals 6/3, or 2 E1 is my expectation value for the energy of the system here.